We're about to leave the port of Heligoland, headed for the permanent research station in the North Sea. Karen Wiltshire and her colleagues are gathering samples today. The water may look calm, but the boat soon starts to sway. It's choppier than it looks. Clearly, marine biologists need their sea legs. And they need stamina, too. Changes to the Earth's oceans don't happen from one day to the next. Researchers have been monitoring the North Sea from their base in Heligoland for generations.
14,3.
We measure the temperature because we've been measuring the temperature for the past 100 years. Every morning on the surface, about 1 meter deep. And we always use the same thermometer. It's a good thing we've been doing this because it shows that the temperatures have been constantly increasing.
The researchers also monitor plankton. As water temperatures rise, the underwater environment has been changing too. For example, over the past few years, the diatom population has increased. Taken together, these observations illustrate how the North Sea is changing, and these changes will affect life on land as well.
Without our oceans, our climate conditions on land would be very different. That's why it's so important to understand how our oceans work. Especially now, when everything is changing, including the Earth's atmosphere. We're observing a rise in carbon dioxide levels, as well as global warming. Our oceans will inevitably change in response, and we need to understand what those changes mean.
The daily water samples have provided the marine biologists with an invaluable trove of long-term data going back more than 100 years. Back in Heligoland, the researchers head for the lab. But these samples aren't the only ones the marine biologists have been collecting from the North Sea. Behind these doors, another project is underway. For the past decade, seawater has been pumped through these pipes 24 hours a day.
Quite a bit of algae, I'd say.
This device is called a ferry box. It's an automated system that works around the clock, recording water temperature, salinity, and pH levels. The data illuminates fluctuations that happen slowly over the course of a day or a season. With this data, researchers can monitor changes taking place very gradually over years. Rising water temperatures are only one of the problems they've seen.
One of the big topics right now is the acidification of our oceans. In one of our major projects here, we're recording what's happening in coastal areas. We're not sure yet whether coastal waters, our coastal waters, will also grow more acidic. There just isn't all that much data on it yet.
What we do know is that the world's oceans are growing more acidic, and marine life is suffering as a result. But knowledge alone isn't enough to make a difference. To preserve our oceans, we'll have to make informed decisions and take action.
Scientists aren't always good at communicating their results and entering into dialogue with politicians and stakeholders. But we're increasingly coming to realize this is a very important part of our work. We need to make sure that the results of our work are accessible to the people who need it.
This lobster is another research project, and it's also an example of the increasingly globalized network of marine research. Heligoland draws many young scientists from around the world who come here to do research. Hiroshi Inoue from Japan studies lobsters. It's an important animal in the North Sea, but it's in danger. That's why Inoue is investigating how local lobsters are coping with climate change. The researchers here say this kind of global networking is essential to preserving our oceans.
Climate change is not only one country can change, so all over the world have to cooperate. So not only one country can solve this problem.
These sea creatures normally live in the project's aquarium. Right now, they're in temporary quarters during renovations. But this rich diversity of species is increasingly vanishing from our oceans. Much of that is due to overfishing. It's another area where urgent action is needed.
That urgency became very clear to me when we removed the fish from our aquarium in Heligoland. I was shocked when I saw the aquarium with just water in it. For 14 years, I've been watching the creatures, creeping and crawling, swimming and eating. Then suddenly it was like we'd switched off the light, just nothing. That's when I realized what switching off the lights in our oceans would mean.
What kind of life will the oceans of the future support? And can it sustain us?